Hello, welcome back. This is Unit 1 Notes, Lesson 4 video, and we're going to cover Section 6, and I mean 6 this time in our notes, the states of matter. We're going to talk about solids, liquids, and gases, and what their properties are, how they're similar and how they're different. As you can see, we have a special guest tonight. This is Eric. He's my youngest son, 7. Well, he's my only son. So he's 7 years old, and he wanted to come on and just lighten your night and share a couple jokes with you because he's our jokester. So, Eric, can you say hi to everybody?
Hi.
Okay, hi. And what do you have to say?
Knock, knock.
Who's there?
Interrupting cow.
So one chance you get to interrupt me. All right, thank you for sharing your joke, Eric. Do you have any more for us tonight? Oh, we get 2 in one night. It is our lucky night. Okay, what's your next joke?
Knock, knock.
Who's there?
Wait. Why did the elephant cross the road?
Why did the elephant cross the road?
It was the chicken's day off.
It was the chicken's day off. Oh, very good. Well, why don't you go cross the road and we'll get to the video so then we can go have some fun. Okay, so we're going to talk about the states of matter, and this animation is up here just so you can see what we really can't see. This is how we believe the atoms move in each particular phase. So if you could zoom in with more than a microscope. So a microscope cannot see this. You have to zoom, 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 zoom in. This is what you would see the atoms doing. And notice what they're doing in the gas phase, bouncing all around, kind of acting like pinballs. Definitely the most motion there. In the liquid phase, the molecules are bouncing around more. They're moving relative to each other. But notice that they're kind of still tight together. They don't really expand to take up the whole space. And then solid molecules, they have the least movement, and they are the closest together in the solid phase. So that is our solid vibrational motion. We're going to complete this chart on the next page of your notes, okay? And we just want to talk about what the arrangement of molecules is for each of those phases. We'll put that into words. So solids have what we call the atoms are arranged in a regular geometric pattern, okay? It almost looks like a Rubik cube, that arrangement of the atoms. We refer to this regular geometric arrangement as a crystalline structure, crystalline. Okay? Liquids have a random arrangement. The atoms in a liquid are free to move about. They can move relative to each other, so they just don't vibrate in place. They also vibrate and rotate. And then in gases, I like to think of that like ballroom dancing. And then in gases, they have a random arrangement. There's no real particular place in a liquid or gas where an atom's supposed to be. They're not locked in one position. So we say that that arrangement is random. As you saw from the video, the type of matter where the atoms have the least motion is, can you guess? Right, solids have the least motion. All the atoms do is vibrate in place. Liquids have what I call as ballroom dancing motion. They vibrate and they rotate and they can move about relative to each other. And gases, the atoms move like pinballs, bouncing off each other. They definitely have the most motion. The atoms look the most energetic in the gas phase. And the reason they look the most energetic is because they are the most energetic. In the gas phase, the atoms have the most motion. We refer to the energy of motion as kinetic energy. So when we talk about the movement of molecules, what we're really talking about here is this kinetic energy. And I'm just going to draw an arrow, maybe. I think I got one. I'm going to draw an arrow here to kinetic energy, okay? Because the movement of molecules is really describing the kinetic energy of the molecules, okay? We have some other things here on our chart. We have forces of attraction, and it's important that you know that the reason that the solid atoms are closest together is because they're the strongest attraction between the molecules. That's what holds them so close together. Liquids have medium forces of attraction, depending on what the liquid is. It can be stronger or weaker. And gases really have weak or even no forces of attraction. Okay, sometimes those are called intermolecular or interatomic forces of attraction. Definite shape, solids do. So if I take my phone and I put it in a cylinder, it's still going to have its same shape. It doesn't morph to the container. So they have a definite shape. Liquids, however, do not have a definite shape. So if you put a liquid in a star-shaped container, it'll have a star shape. If you put it in a SpongeBob SquarePants shaped container, it'll be SpongeBob SquarePants shaped. And gases also do not have their own shape. They take the shape of their container. And finally, we have volume. Solids have their own volume. A solid takes up the same amount of space no matter what container it's in. Liquids also have their own volume. While they'll take the shape, they still maintain their volume. So if you pour 10 milliliters of water in a star-shaped container and then dump it on the floor, it's still 10 milliliters of water. It doesn't spread out and occupy the volume of the floor. And then finally, gases do not have either. They have no shape, they have no volume. That is a characteristic of the gas phase. And pay attention tomorrow when you're in my classroom, and you're going to see that on the periodic table, the elements that are gases at room temperature have a red symbol in my room. The elements that are liquid at what we call STP, those are blue, and the elements that are solid at STP, those are black. Okay? What I'd like you to do for tomorrow is, tell me one element that exists as a solid at 0 degrees Celsius, one element that exists as a liquid at 0 degrees Celsius, and one element that exists as a gas at 0 degrees Celsius. Elements are the things found on the periodic table. So this is something you're probably going to have to Google because you're not going to be in my room to take a look at that. So we're looking for on a sheet of paper so you can turn it in. Don't tell me you did it in your notes. I want one liquid at 0, one solid at 0, and one gas at 0. All right, I hope you laughed. I hope you had some fun, and have a great night. We'll see you tomorrow. Bye-bye.